signal is a continuous time signal with a spectrum shown in this graph. And then you take sample with different sample period t. T, I have the first problem, I have 3 choice. And the second problem, I have A, B, C, D, F, six different T's. So for every fixed T, you choose a T. And then I want to see the first one, let X, this one, and this is your favorite. And sketch. Okay, this is a sample, right? This one is a sampled signal, and this is a how to say, the XS, that signal obtained from the sample signal in continuous time signal, right? And this one is also this one. Okay, second problem, we just want this capital X. This is a DTFT of the sample signal. Similar, right? Similar thing. So both is kind of practice. You can try. You can try if you just look at me do it. You can only know few things. You know, this is things like for example, you drive or you buy a bike. You know how to buy a bike? At least you can see some people buy a bike, right? Just step on it and sit on it and step on the pad. Then you can ride a bike. But if you do not practice, you never know how to do it. This is similar thing. You do it, then you understand how to do it. If you just look at it or just look at me, it doesn't work. So I show you, but then after the class, you need to do it by yourself. All right? This is okay. Let me do that. Can you see? What are you talking about? It's doing sampling theory practice. Yes. So I just suggest you need to do it, but you need to do practice, not just listen to me. All right. I show you one here, and you need the. Okay. So we have a continuous time signal with continuous times Fourier transform, which is a capital X C J omega, and it looks like this. And the values, Okay, here's a 40 pi, and here's a 2. Okay, and then we take sample. We have x n, which is x c of n times t, and t that is varies, right? We have a, b, c 3. So let me pick one. For example, I choose this one, 0.025. I use this one, and we want to know the sketch xc, not xc, x xe to the j omega and xs of g capital omega. Okay, let's go back to the paper. All right, here. Okay, so we have the signal looks like this, and we take sample by step t, and we sketch the Fourier transform of the sample signal, this one. And also this is a Fourier transform of xs of t. Okay, so we want these two. So firstly, you should know this. What is this? We have a formula right here. x e to the j omega. This is 1 over t times the summation of x c j of now is omega minus 2k pi over t. So you need to know this. The graph, you sketch it. Actually, it is a realize of this form. Here's a k run from negative to positive infinity. You should know what it is, right? As a signal, when you minus something, this is a shift of the signal, right? Shift by 2k pi. This is shift by 2k pi. So this is this one. You have infinite copies centered at 2k pi. So 0k pi, 0k, k0, this is 0. Then this is a 2, k is 1, 2 pi. And here's a k is 2, so this is a 4 pi. Right? This side is negative 2 pi, negative 4 pi. So every center we will have xc. So xc looks like this. But now this is not just xc. You have divide by t. So xc of j omega over t. What is this? Do you have any idea about these? Do you have any idea about these? I'm working on this one. I'm working on point. Okay, you want point 3? You can try it. You do it by yourself. All right, Ali. You do that 0.03 by yourself. And I'm working on this point 0.025. Similar thing. All right. Okay. Now I have a question. I have a question here. I have a question here. This one. You know what is the graph of this? Any idea about this one? You know this. This is a xc. Xc is this. And you trace this capital omega to be omega over t. And what is graph of this? Any idea about it? Yeah, disappear. Yeah, it's a homework. No, not in part. Not in part. So you should know that. Actually, when you have signals, uh, okay, before I start, I do this one. Okay, if f x looks like this, here's 1, here's 1, here's 1.6, here's 2. This is f. Then f2x is what? Can you give the graph of this? What is this? You know this one? I just think you should know this. Yeah, where's the chat? Okay. Right. What is the graph? How to give the graph of it? It is f of 2x. Then what is the graph of this f of 2x? Any idea about it? Here's x. Here's x. Here's f of 2x. It all looks like this. Okay, so what is the value here? Any idea? 4? No. You plug in x equal to 0. What will be the result? You plug in x equal to 0. X equal to 0. Okay, good. This is 2. It's 2. All right. And this point, What is the value of this here? X equal to 1. Here's X equal to 1. And here X were equal to 1. Still 2? No. Huh? You plug in 2 here, what will happen? F of 2 times 2 is 1. Yeah, F1 is 2. But here is 1. This point is which point? X should equal to 1. So F of 2x. If X is 1, you plug in, it will be F of 2 is here. F of 2 is 0. Right. 1 over 2. You get it? If X is 1/2, this is F X. If X is 1/2, this is F of 2 times 1/2. So this is F1. This is F1. Yeah. So you see, when you times a constant in inside the function variable, you times 2 here, then the result function, this F of 2x, it is a kind of you press it. You press it. You times 2 here will be smaller. And if you divide by 2, F like X over 2. This one. Now this one, here will be 2, here will be 3 point. This is your 2. This is or looks like this. You can see both. Yeah, this is F. This is F. This is F of 2x. This is F of half x. All right. So this is one thing. Actually, I think we use these a lot. When you're faced with a signal, you need this kind of thing. So you change the scale of the variable. You change the scale of the variable of the function. Okay, this is one thing. And the other thing is, okay, I still use this as F. This is Fx. Right? Here's 1, here's 1.6, here's 2. So this is a X, this is F. All right, we have this one. Then what is F of X minus 2? What it is? Any idea about this? The whole function, not 3. Whole function. Shift, yeah, shift to the right by 2. Okay, now you get it. Shift to right by 2. So this one is 0, 1. Now should be 2 and 3. And here will be 3.6. So now the signal looks like this. And here's still 2. All right. It's the shift. Okay. Now we should know what is this one. Now suppose this is xc of j omega. Then xc of j omega minus, okay, I just use 2 pi over t. What is this one? You see, we have shift by 2 pi, shift by 2. This one is shifted by 2, right? This one is shifted by pi, by 2 pi. So this one well, looks like here's 2 pi. This one shifted to the right side by 2 pi. So it will be something look like this. And also divide by t. Divide by t, that means you are times t. So the thing looks like this. Here, the distance here, suppose this is we have 4 pi, right? No problem. It's 40 pi. Okay, 40 pi. Here's a 40 pi. 40 pi. Then this distance will be 40 pi times t. So here divided by t, it will be times t. You make here and in the variable. This is a capital omega. This is the lowercase omega. Yeah. So we have things look like this. So from here to here, we change this one to this one. This one looks, depending on the t. For small t, smaller t, it will look like this, right? Because this distance will be smaller. This is smaller. This is a 40 pi t, right? Smaller t, small t, and the larger t. Like this, right? This one for this smaller t. This one still for consider this one. These three are same. These three are same thing, but different t. This is I just put in normally. This is then smaller t look like this. Larger t, it will be okay. Here is still 2 pi, and it will looks like this because t is large. Here is a 40 pi t. T is large. T larger than distance longer. All right. T could be any value. Smaller one, yeah, smaller one is smaller than 1. Actually, here, this if I use this one, this t is also smaller than 1, right? This is 1. This is like a 0.8 something. Right? This is 1. This is 0.8, and this is even smaller, like only 1/3 or 1/4. And this one is large. I use maybe 2. Yeah, you can use any one. Go back to 310 nodes for this. Yeah, you should have that. Okay, 310, you have that? Okay, that's great. So you should know this. All right. Okay, after this, then we can have our problem is here. Now let's go back. This is XC. This summation of all of these, and each one. Okay, here I use a small t. All right. Things look like this. T is small, right? T is small. This is small one, 0.25. And the distance here, that should be 40 pi t. And the t is 0.25. This is t. And the times 40. This will be 001. And one more 0 way like dies here, right? So there will be just 1. So this is 1 equal to 1 of pi. This is equal to pi. This is pi. Oh, this is a pi. Okay, this is a pi. There will be my graph is too small. This should be pi. Should be pi. Should be in the middle. Okay, let me change. Should be in the middle. This is 2 pi, right? This is 2 pi. So look like this. Okay, so look like this. This should be is here. From here to here is 40 pi t, and t is this one, and 40 pi I get 1 pi, right? 40 times 20.225, right? 0.25 times 40 equal to 0.25 times 4. Okay, this is 1. This is 1. So this is a pi. Okay, so we have the graph of this one. Here's omega. Look like this. And this value, here's a 2, right? Here's a 2. And here you divide by t. So this will be 2 divided by t. Is 2 divided by 0.025, which is 20 over 0.25. Times 4, this is 80 over 1 is 80. So the peak value here will be 80. Now you have the graph. You have the graph. You got it? So actually this problem is not difficult. But you should know what is graph of this part. Here we have 2 things. One, we have shift on omega. Every 2 pi you have a shift. And we have a change on the scale is divided by t. So here you need a times t. Here you need times t. So like this way is 40 pi, and here will be 40 pi times that t. It is just pi. Is it clear? Ivan? Where nodes beyond Blackboard? Actually, you have solution. You have solution. I have solution for these problems. You can see. I think the solution is quite. But I didn't record actually. I didn't record. You have the solution. Why not? I forgot. Sorry, I forgot to record. I already finished. I have finished it. Yeah? Now, if I record just this one, but I finished it. You can see the solution. Let me go to the solution. Here's okay. This is just problem. Okay, this is just problem. Let me go to the solution. This one. Okay, you can see. I gave all the details here. This is original one. Then X is this. This is X. This is the Fourier transform of that DTFT of that symbol thing, right? So you have T. Now this is capital T is 0.02. Then the peak value or 2 over T is 1. And this distance will be 40 pi times this T. 40 pi times this T. This should be 0.8 pi. 0.8 pi. Okay, I put 4 over 5 pi, the same thing. Right? This is 4, 5 pi. 4, 5 pi. This one. Oh, the solution no formula. Yeah, this is just I did. Right? Oh, this one just okay, no formula. Okay, then I can yeah, I can put this page, put this as a node. All right, this page as a node. So you have this graph, and you have the formula. This graph actually it is realization of this formula. These two are same thing. Same thing. One is described by a formula. One is my check. One is one is graph. One is a formula. Right? This is formula. This is formula, and this is graph. Formula and the graph. And why I can't see you chat? Chat ball work? Okay. Oh, someone put something here. My chat bar just disappeared. I just coming back to the chat bar. Sampling theory xj omega 2. From this, I think the solution of this is wrong. I will try to. Oh, you think solution this is wrong? Oh, I think we just check it. I think it's good. Yeah, this is 3. 3. 3 will be See this one? Okay, this is X. This is X. So original one, here's a 2, here's a 40 pi. This is the X C J omega. I copy this in my paper. And then T is 0.03. Okay. Right, we have this one. We have this one. Then X of e to the j omega. This one. So every 2 pi, we have a copy. Okay. Every 2 pi, we have a copy. This is negative sign. And each copy, here T, this one. So we will have a kind of triangular. This distance will be 40 pi times T. So what is that? 40 pi times that T, right? Here's a 40 pi times this T. Okay, you should remember, if this value is different, here will be different. All right. Now 40 pi is a 40 pi. Here's a T. T is a 40 pi times 0.03, which is how much? 0.03 times 40. It is 0.3 times 4 is 1.2. This is 1.2, 1.2, 1.2. This is 1.2. So this is 1.2 pi. This is 1 pi in the middle, right? Then a little bit more. So it looks like this. Looks like this. And then at the 2 pi, you have copy. This is 1. So this distance is 1 and 1.2 will be it. So it looks like this. And here at 4 pi, we have another peak. Right? So it looks like this. Got it? This is the homework for last part. Yeah, Judge, this is the homework for last part. And Jen, you can see the file. Is it because I'm in a bar project? Is everything good right now? You hear me? Why this is even in a private? Oh, what I did. Can you hear me? It's not just for event. Everyone can hear me, right? Yeah. Why is it private again? Oh, I can email. I can call you individually, one by one. All right. I prefer to all of you guys. All right. Okay. That means. All right. All right. So, who said you think this is wrong? Let me see the solution. Yeah, you see this one. This one is 6/5 pi. Actually, this is 1.2 pi. Right? I calculated 1.2. This one is put 6/5. The same thing. Same thing. See? Yeah. Got it? So right. These are license. So in this case, just by a field, it is impossible to restore the original signal. You cannot restore the original signal. If you use a low pass filter to cut off, you will have things look like this. You will have things look like this. So suppose we have this one, right? If you cut off, this is the edge. Then by this edge, you will have the thing looks like this. And this is original one, this one. And you take some bone and then by a filter edge to cut off, you get this one. So this is different, right? In frequency domain, they're different. And of course, they are time domain, they are also different. You get different signal. So you cannot restore. You try to restore, but you get something different. All right. Right, you can. So this is the case you can restore. So in this problem, we have three cases. We have three cases. Right. This is second. This is first case. First case. This is first case. First case, each copy they are separate, totally separate. So you can restore it. You can restore it just by a low pass filter, and you can get a original signal. And now this T is a 0.02. This is smallest one, smallest T. Then second, we use a T a little bit large. Then you see each copy, they have a common point here. So when you do a field at this point, so you were lost one value, but just one value. This value is actually here. This is 0. You lost the 0, so you lost nothing. So in this example, you can totally restore it. Even T is just this is Nyquist time step. Nyquist time step to take sample is fine. You can restore it. And the last one, this one you can't because they have overlap. When you cut off here, when you cut off at this place, you get you get a signal with different spectrum, different Fourier transform. So you can't restore the original one. All right. Okay, so this is for x, for this x, right? And similar, you have xs. So what is xs? We can go back to the formula. You can see what is xs. xs, you should know this. xs of j omega. We also have formula. This is 1 over t summation xc, xc, j times capital omega minus 2 pi over t. Looks like this. Okay, run from negative to positive infinity. So you see, okay, here's nothing. It's similar. We have a lot of xc. Each xc in omega, in capital omega, we have a shift by 2 pi over t. Now I have a k. Yeah. And this is shift by this. And no scale with this one. With this one, this omega divided by a capital T, right? Divided by capital T. And this one, capital omega is still capital omega. So here no scale, just a shift. So you will have just a shift by 2 pi over T. Shift by 2 pi over T. Right? Every 2 pi over T, you have one copy. You have copy. And the scale will be no scale change. So here will be 40 pi. Here's still 40 pi. Still 40 pi. And you need to determine what is this value. That depends. For example, if I use this 0.03, for this 0.03, then 2 pi over t, 2 pi over t, which is 2 pi over 0.03 will be 20 over 0.3 will be 200 over 3 pi. That will be what? 66.60 pi. Right? So this point is a 66.6 pi. Things like that. And we have a copy Okay, so if here's a 66, then 40 should be here. 40 should be here, right? 40 should be here. And you have a copy of this here. That will be look like this. And this point will be start from 66.6 pi minus 40 pi. There will be 26.6 pi. So here's a 26.6 pi. All right, we check the solution. 0.03. Yes, 30. 60. Oh, yeah, this one getting something wrong. Oh, who told me you find some mistake? Yes, yes, there is mistake. This part is some mistake. The scale they put in the wrong way. Here's a 40, 66 should be in the center, not at this point. Should be the center. This should be the center. Okay, thank you. Who find that? Who found that arrows? I thought that you are good. I thought the solution are good, but actually it's not good. Yeah. It should be. I suppose I need a rewatch the previous lecture. I thought it was filter related, didn't see. What was 6 OPS? What is OPS? So what is posted on the test and homework? The homework you should know. You see, I have this one. Homeworks for the last part. This part we do not have quiz. We have quiz 1, quiz 2, quiz 3, then midterm, then quiz 4, right? And the last part, we have sampling theory. You need to check here. You check here. We have 3 problems from textbook for the 12, for the 20, and for the 21. We have these 3 problems coming from textbook, and I also give you 2 problems here. Homework for sampling the PDF. 2 problems. The first problem has ABC 3 small problem, and second has ABCDF 6 small problem. And the solution of these homework solution for sampling 1 and sampling 2, they are according to the first and second problem of this homework. And the solution of homework problem for the 20 and 21, and the solution of for the 12, right? So this is the last part. This is the last part. And the problems for chapter 4 is here. Okay. So beside the homeworks for the quiz 1, 2, 3, 4, and homeworks for midterm, you also needed the homework for this part. Homework for this part. Got it? We should be good if we review all that stuff, right? Yes. So it is on quiz 1 to 4, midterm, and the sampling homeworks. Right. You're welcome. No problem. When's the final? Oh, this is Monday morning. Monday morning. So now it's Friday. You have 2 more whole days. So we are the first. We are the first exam, right? First exam in the final week. Maybe you already finished some exam now, right? Should we just redo the quizzes or again, or do all the related homeworks to those quizzes too? Well, according to the time, I think do you have time for all the all the homework problems? So like now, if you ask me, I think you can only finish all the quizzes problems and the whole midterm problems and the last part. You only have 2 days, right? If you want to try to finish all the problems, then you need a lot of time. Do you have so many times? If you have, you can do more. No, but if you didn't, then you just try the quiz and exam problems. You have other, yes, I know. So, yeah, sure, it will be easy. But in case you understand how to do it, you know. For example, now for the sampling, if I ask you to sketch a Fourier transform of the sampled signal, can you do it? Yes, from 8 to 10 is exam time, and during that time I will be on site, so you can reach me if you have question, you can ask me. And after 10 I will not be there, and that is for you to prepare files and upload to the Blackboard. Yeah, the problem I will post in Blackboard. That will be similar with the last quiz, you know. George, did you take part in the last quiz? I said you didn't. You told me someone proved you attend, but I just feel you didn't attend that. Did you, George? You did. So you should know where to get the problem, right? Yeah. Okay. Now you mind. You remember, right? Yeah. You got it. The same way. Same way. I will post the problem in the Blackboard in the uh, you can find the quiz 4. You can find quiz 4. You go to quiz 4, have a look at quiz 4, and the final exam will just follow quiz 4, the same place at quiz 4. But now you don't have it. You will have it by the 8 o'clock in the morning of Monday. Of course, it will be a little bit early, but just a little bit early. And I suppose you will have like 2 hours to do it. E-learning has not been easy, yeah. And curve, I think I will do some curve, yeah. But now is you know you try your best to review, and I will try best. If you have any question about the material itself, I will answer you. As for which will be A, I cannot say it right now. You know, normally it should be 80. Should be 80 for B, right? If I curve, maybe like 87 for A or 85 for A or some 80 something for A. Uh, I will see. Actually, I will see how well you do in the final exam. No, I can't determine right now. Actually, so maybe something happen like this. For example, if I use 80 as A, maybe you get like almost 80 percentage of you guys get A. I don't think that is a right standard, right? But I think you will be fine. The last two labs are not greedy. Uh, okay. Oh, last two labs. I think depending on TAs. Some TA agreed, some TA didn't. And different lab times. Some of you have lab session Tuesday and Thursday, right? So Tuesday should be fine. And Thursday should be later. but don't worry about it. The lab definitely will be graded before I give you final grade. You know, I will calculate all your points, include all the labs, together with exams and quizzes. Then we have a weighted total. Then I give grade based on weighted total. All right. Actually, I already have the weighted total. You can see what's your weighted total. You can see if you're, like, for example, now you have weighted total. For example, you have 55. Then final, if you get 90, then you need a plus 90 plus times 3 will be 27. So you plus 27 on your weighted total, right? Things like that. If you final you have 100, you can add 30 for your weighted title, weighted total. If you give up, you just do nothing for the final, then that final you add 0. You will have the point just as the weighted total right now. But I think you won't give up, right? You will do it. You will do it, and you will do good job, and you will have good grade. So the percentage that is on Blackboard grade is what we have now. So what around the total point? Right, right. The weighted total. You have 30 more for your weighted total. That 30 is coming from the final exam. Okay. Any more questions? No. Midterm paper is in my office, but I have solutions. I have solution of midterm, so you can look at the solutions. All right. You look at the solutions of midterm, and I suggest if you have time, you can do the midterm by yourself. Don't look at the solution. You do it by yourself. When you're done, you compare with the solution. Then you know which part you're getting wrong, and then you know how to create, so how to correct it. Okay. Yeah. Okay. I will see time is almost the time, and then Monday will be the exam. So like if you still have problem, you can email me, right? Saturday, Sunday, if you have still have question, you can email me. Then Monday will be the exam. All right. And I can I can put this last one in the Blackboard. The graph of the sample signal, the Fourier transform of the sample signal. All right. Okay. See you guys. Have a good evening. Have a good afternoon, and have a good weekend. Actually, basically for have a good luck in the final exam. All right. Not just my class, all the classes. Okay. And see you guys.